Alright, let's get started. Number 1. Explain how to find the input variable in a word problem that uses a linear function. So the input variable is the independent variable. Think of the horizontal axis, the x-axis, that's the independent variable. The y is the dependent variable, the vertical axis. So the linear function will act upon the independent variable and will give you an answer or an output. Alright, and that's what you're usually trying to find out. You're trying to find the output of the linear function. You plug in the independent variable and out pops the output. Alright. Okay, number 3. Explain how to interpret the initial value in a word problem that uses a linear function. So when they say initial value, they mean the value of the function when the input, the independent variable, equals 0. When x equals 0, usually it's x. Alright. So this can be taken as the starting point. Alright. Alright, number 5. Find the area of a parallelogram bounded by the y-axis, the line x equals 3, the line f of x equals 1 plus 2x, and the line parallel to f of x passing through the point 2, 7. Alright, now this is quite an involved problem. There are several steps to solving this, and this is probably by far the most complicated problem in this section. It's not that it's super difficult, it's just a lot of steps involved. So whenever you have something like this, it's a good idea to draw pictures of the situation and come up with a general strategy, because there are multiple steps you have to do, and that could confuse you if you don't put it down on paper and draw your pictures and whatnot. In order to do this problem, we're going to need at least 2 formulas. Alright, we need to find the area of a parallelogram, and I haven't really searched through our book to see if there is such a formula. Alright, but there are reference books available. Of course, there's the internet. Look up area of a parallelogram. Reference books, math reference books. Here's a famous one. Pardon me for a second while I retrieve it. This is an old copy that I have. The CRC, Standard Mathematical Tables, Chemical Rubber Company. Alright, they've been publishing these for years. Now, as far as I know, they're still publishing these. This is an old copy that I used. It's pretty big. They used to make small editions, pocket-sized ones. Back in World War II especially. You find these in used bookstores. Alright, go to a used bookstore, and if you're lucky, you might score one of these pocket-sized editions. Alright. So this one is, well, not exactly pockets. Well, it'll fit in a cargo pocket. Alright. And there's also this one that I picked up a long time ago in a used bookstore. This is a little bit bigger, but it's still smaller than that first copy I showed you. And I thought this was cool because this belonged to somebody in the Navy back in World War II. And Mr. Witter, if you're out there, I have your book. And I'm a former Marine, so I can relate. Except in the infantry we didn't need these. But who knows, you probably needed it. Anyway, you can get those. They have all the formulas you'll ever need, all right? For mathematics, it has geometric formulas, that sort of thing. Okay. But yeah, you can look it up on the internet nowadays, so you don't even need these books, I don't think. But if your computer doesn't work, there you go. Open the book. But here is a parallelogram. As Alan Sherman once said, it's just a crazy square. And if you're a certain age, you'll understand my reference. Anyway, here's a perpendicular to B. We'll call it H. That's the height of the parallelogram. So the area of the parallelogram is equal to BH. This base times the height. All right. Okay. And there's also a need for a formula for the distance between 2 points. Okay, and there is a reference to that in the book. Just look in the index. Look for distance formula. Distance formula. All right. Now it's way in the back of the book, which kind of surprised me, but it's not in. I can't find a table of formulas per se, but it is mentioned toward the end of the book, and as if it comes out as if it had been talked about before. All right. It's based on the Pythagorean Theorem. Okay, so that's how they derive the formula. I'm not going to get into its derivation right now, but if you have 2 points x1, y1 and x2, y2, then what's the distance between them? The distance, lowercase d we'll call it, is equal to the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Alright. Again, that comes from the Pythagorean Theorem. I'll draw you a quick little diagram of what's going on, just in case you're curious. Here's x1, and here's x2, let's say. And let's say that's y1, and that's y2. So we have the point x1, y1, and x2, y2. This is distance d that we're looking for, and this little diagram forms a right triangle. Okay. Now what's this distance here? This is y2 minus y1, and this distance is x2 minus x1. For example, if x2 were 5 and that was, let's say, 2, this distance would be 5 minus 2, which is 3. Alright? So distance d squared is equal to this distance squared plus this distance squared. And then if you want just d, take the square root of both sides, and you'll end up with this formula. Okay? Now, notice the order it's written, x1 minus x2. Over here you got x2 minus x1, same with the y's. Is that going to make a difference? No. Because if you take y2 minus let's try y2 minus y1 squared. That equals, bracket, I'm going to put a negative, and then factor out a -1 from these two. That gives you y1 minus y2, and all that's squared. See, I'm doing all of this inside the parentheses, so I'm putting brackets, there's a square. I'm factoring out a -1 from these two. If you put the -1 back through, distribute it back through, you'll get -y1 plus y2, which is what you had here. Alright, so these are equal. This is actually a -1 factor. Oops, don't want that to be a... That should look like a -1 there. Alright, and this is equal to -1 squared times y1 minus y2, quantity squared, like that. So if you, in other words, if you have ab squared, that's equal to a squared times b squared, right? You can, as long as you're multiplying or dividing, you can split it up like this. Okay, so got the same situation here. You got -1 times this quantity, and you're squaring everything, so you can put the square on the -1 and the square on the y1 minus y2. -1 squared is +1, so it's just this, y1 minus y2 quantity squared. So in other words, y2 minus y1 quantity squared equals y1 minus y2 quantity squared. Okay, maybe you didn't realize that before. All right, that might be a little surprise to you. All right, so this is the distance formula for the distance between 2 points in a plane. All right, so we're going to need these two formulas. And now let's take a look at the situation and come up with a strategy. All right, so we've got, what do we got here? I'm going to make a rough sketch. I'm not going to make anything exact. I'll show you a more exact sketch in a minute. But let's come up with just a rough sketch first. You don't have to be super precise when you do these rough sketches, right? Just come up with some ideas. We've got x equals 3. That's a vertical line. And what else do we have? We have y equals 1 plus 2x. Alright, that's a line that goes through y equals 1, and it's got a slope of 2. So just to make an approximate line like that. And then we've got a parallel line going through the point 2, 7. Let's just say 2, 7 is here. Alright, so you've got a parallel line going through like that. Parallel to this line. Alright, what else? And we need to find the area of the parallelogram that's formed by the y-axis and this x equals 3 and these two lines here. So we're looking at this this parallelogram that I'm outlining right here. Alright, we need to come up with the height h, so that would be something like this. Alright, it has to be perpendicular to those two parallel lines. Now where we draw it can make a little bit of difference in the amount of work we have to do. So why don't we draw the h here, right there, because this point here has 0 as an x-coordinate. Anytime you have a 0 in your formula, that makes it a little easier to calculate. Alright, saves a little time. Instead of, you could do it from the point 2, 7, like here. Well, I kind of drew it a little bit off, but you get the idea, right? Let's say that's 2, 7 right there. Okay, you could use that as a reference point. You could, sure, you could do that. But it'll involve a little more work. Why bother with a little more work, right? Do it the smart way. Get zeros wherever you can, wherever it's a gift of God, right? Alright, so now what? Well, how do we get, once we know what this is, well, first of all, we're going to also need to know the length of one of these two lines here. Let's call this B here. this length, this distance here to here. Alright? Well, we know what that point is. And that's the y-intercept of the parallel line. And this point has x-coordinate x equals 3. What we need is the formula for this line, which we can get. We have enough data for that. We have enough information for that. And so we can get the distance between these 2 points and call it b, all right, using the distance formula. Okay. So here's a more precise picture that I use my computer to draw of the situation. And you'll notice that I've already put formulas on there. But I'm going to show you how to get those formulas in a second here. Alright. Okay. So what we need to do is get the equation of the line parallel to f of x equals 1 plus 2x, which passes through 2, 7. In other words, we need the equation of this line here. Okay. And so we have a point, 2, 7, that it goes through. And we also know the slope. It's going to be the same slope as the line they gave us. And that's going to be slope 2. Alright? So we can use the point slope equation, y minus y1 equals m times the quantity x minus x1. Alright? So the point is 2, 7, so we've got y minus 7. The slope is 2, and that quantity is x minus 2. Alright? So that's 2x minus 4. There. And then add 7 to both sides. You've got y equals 2x plus 3. So now we know the equation of the parallel line. Alright? Y equals 2x plus 3. Okay. And now what we need to do is find h here, the height. Alright, so to do that, you pick a point on either this line, y equals 2x plus 3, or the line they gave us, f of x equals 1 plus 2x, and use the slope for the perpendicular to those lines, which is -1/2, right? The slope of these lines is 2, so the perpendicular will have slope -1/2. It's the negative reciprocal of 2. Okay, so then you use the point slope equation. All right. Now we said we were going to use this point here, which is the y-intercept of that line there. What's the y-intercept? It's 0, 3. You can see it, read it right off of there. Okay, so we'll use the point 0, 3 and the slope -1/2. All right. First, I'm going to have to do a little erasing. Okay, so we're using the point 0, 3 and m equals -1/2. And you can use the point slope equation once again. Y minus y1 equals m times the quantity x minus x1. And so we've got y minus 3 equals -1/2 times the quantity x minus 0. That's where the 0 comes in handy, and so that's just -1/2 x. So y equals -1/2 x plus 3. Just transpose that -3 to the other side. So that is the equation of this line right here, this h. All right. Now, the only thing we're missing is this point right here. Where does it intersect with f of x that they gave us? We know what that point is. But we need this point in order to figure out the height. Okay, we need to use the distance formula for the distance between these 2 points with this line. Okay, and get this distance h. All right. So what we want to do is find that point of intersection. So what we do is we set this equal to f of x equals 1 plus 2x. All right, let me erase some more here. Okay, so again, we're going to find the point of intersection of y equals negative 1/2 x plus 3 with f of x is 1 plus 2x. So we set this negative 1/2 x plus 3 equal to 1 plus 2x. And then you're going to solve for x. So we can subtract 1 from both sides, move that to this side. We're going to move that to that side. Alright, so 3 minus 1 on the left side equals 2x plus 1/2 x on the other side. And so 2 equals, and 2 plus 1/2, 2 is the same as 4 over 2. 4 over 2 plus 1 over 2 equals 5 over 2. So you got 5 over 2x. And then multiply both sides by the reciprocal of 5 over 2 to solve for x. So you've got 2/5 times 2 equals 2/5 times 5 over 2 x. And y multiply both sides by the reciprocal of that because this will cancel here. And that leaves you just with a 1 times x, which is just x. And so 2 times 2/5 is 4/5. Alright, so x equals 4/5. Alright, we're not quite done. We need to substitute this into the formula for f of x to find the y value of that point. Alright, if you look back at the diagram of the situation, we know the x coordinate is 4/5 right there. We already calculated that, and this line here down below is f of x equals 1 plus 2x, as you can see there. Alright, 1 plus 2x. So we need to substitute that x value into the formula for 1 plus 2x, and I know I already have it written down, but you need to see how to get that, right? So let me erase here. A lot of erasing with this problem. Okay, so substitute x equals 4/5 into f of x to get the y value. So we've got 1 plus 2, and then x equals 4/5. And that'll give us the y value. Alright, so that equals 1 plus 8/5. And 1 equals 5/5. 5/5 plus 8/5. 8 and 5 are 13, so that's 13/5. Alright, so that means the point of intersection is 4/5, 13/5. Alright, so what we need to do now is find the distance h, the height h. As you can see in the diagram, once again, alright, there's our point that we just calculated. we know what that point is there already, and we use the distance formula to get that distance h. All right. Okay. So we use that with the point 0, 3. So these 2 points. All right. So we've got h is equal to the square root of 4/5 minus 0, quantity squared, plus 13/5 minus 3, quantity squared. Make sure your radical goes all the way across and covers what it needs to cover. Alright? If you just draw it part way and some parts of it are left out, technically that's incorrect. Alright? And your professor could dock you for that on a test. So be careful. Alright, so this is equal to square root of, all that is just 4/5 squared, which is 16/25. And then this one, we need a common denominator with the 3, so multiply 3 by the -3 actually. -3 times 5/5. That gives you 15/5. So 3 equals 15/5. Alright? So we've got 13/5 minus 15/5 squared. Alright. So this equals square root of 16/25 plus, that's going to be negative inside the parentheses, that's going to be -2/5. 13 minus 15 is -2, and then you're going to square that. Alright, square -2/5. So that equals 16/25. And that becomes positive 4/25. Alright. Because negative times negative, when you square negative, you get a positive. So it's 4/25. And then they have same denominator, so you could just add the numerators. That's 20/25. Square root of 20/25. Okay, so we can simplify this square root. We're kind of, I mean, you'll be doing this later in the book in more detail, but that's okay. You've probably done this before. I hope you have. You can factor 20/25 as 4 over 25 times 5. 4/25 times 5 gives you 20/25. And in other words, 4/25 is the same as 2 squared over 5 squared times 5. 4 over 25 times 5. Alright? And now you can split it up. That's the same as 2/5 in parentheses squared times the square root of 5, like that. Alright. This equals that. Okay, 2/5 in parentheses squared equals that. Okay, so that comes from the rule, where can I draw this? A over B in parentheses squared equals A squared over B squared. Alright, so you take the square root of 2/5 squared is just 2/5. So that's 2/5 square root of 5. Alright, there you go. That's h. That's h. 2/5 times the square root of 5. That's the exact value for h. Okay? If you use a calculator on this, you'll get a value, but it won't be exact. It'll be an approximation. This is the exact value. Okay? There you go. Now, what we need is the length b. The length b. What was b again? Here we go. Back to the diagram. It's good to keep that diagram around that you drew. See, there's your length b there. You got to get that point there. We already know what that point is. The distance between those 2 points would be b. All right. Okay. So again, I need to do some erasing. All right. So hold on. Alright, so we need b, and we can get this point here. That point is 3, 9. Alright, x equals 3. We already know x equals 3 there because that's the line they gave us, x equals 3. So substitute x equals 3 into the equation of this line, y equals 2x plus 3. 2 times 3 is 6 plus 3 is 9. Alright, so that's the y value, 9. Okay, so that's the point 3, 9. And so we need to find the distance between 0, 3 and 3, 9. Alright, so that would be b. That would be the distance. So that equals 3 minus 0, quantity squared, plus 9 minus 3, quantity squared. And that equals square root of 9, 3 squared, and then 9 minus 3 is 6, 6 squared is 36. And that equals square root of 45. We can simplify that a little bit. That's square root of 9 times 5. 9 times 5 is 45. And that's equal to square root of 9 times square root of 5. Square root of 9 is 3, so that's 3 square root of 5. Okay. So that's the exact distance, b. The exact answer. Alright. So what's the area of the parallelogram? Finally. Let me erase some more. Hold on. We'll get there in a second. Alright, so what's the area? It's BH, right? BH. So that equals, B is 3 square root of 5 times H, that's 2/5 square root of 5. So that equals 3, you can move that 2/5 out over here, 3, using the commutative property of multiplication. You can use that a couple of times. 3 times not square root, 3 times 2/5 times square root of 5 times square root of 5, or square root of 5 squared. So 3 times 2/5 is 6/5. And then square root of 5 times square root of 5 is just 5. Alright? And this is nice because this cancels with that. So you just get 6. Alright? So the answer is 6 square units. Square units. Square units would be the unit that you would use for area. they don't specify these original measurements, all right? And so if it were in centimeters, you would say square centimeters. If everything was in centimeters, or inches, square inches, all right? But they didn't specify the units, so we just say 6 square units, okay? All right, wow. That should be the end of the section, right? But hey, we got a lot more to go. So that took a while, but I'm glad you're still there, all right? That's how you do it.